Hello everyone. In this video, we will cover the end-year term insurance. In the previous two videos, we covered the one-year term insurance as well as the two-year term insurance. Now, we consider an end-year term insurance issued to an individual at age X with death benefit of 1 payable at the end of the year of death. Let Z be the present value random variable for this insurance. If the individual dies before reaching age X plus 1, a death benefit of 1 is payable at this time point. The present value is new. The probability is Qx. And if the individual dies in the second year of the policy, the corresponding present value is nu square. The probability of this event is 1 bar Qx. The general term, the individual dies within 1 year before reaching age X plus K. The present value is nu K with probability K minus 1 bar Qx. And then the last present value is nu N with probability N minus 1 bar Qx. If the individual survives beyond age X plus N, then the insurer pays nothing. Z equals 0. And any one of this present value together with 0 can be one possible value of Z. This is the PMF of Z. Z is nu raised to the power Kx plus 1 if Kx is less than or equals N minus 1. And of course, Kx must be an integer. And Z is 0 if Kx is greater than or equals N. The expected value of Z, by definition, we sum up the value of Z times the corresponding probability from K equals 0 to N minus 1. The probability K bar Qx can be expressed as Kpx times Qx plus K. The actuarial notation, the big A notation, X colon angle N, and then a 1 above the X. The second moment, the expected value of Z squared. By definition, we have this expression. And then compare these two expressions. The expected value of Z squared, this simply is the evaluation of the expected value of Z at a double force of interest. Therefore, we can add the pre-superscript to denote the expected value of Z squared. And the variance is standard, the expected value of Z squared minus the square of the expected value of Z. Okay, so what if the death benefit is BK, payable at the end of the year of death if death occurs between ages X plus K and X plus K plus 1, for K equals 0, 1, 2, up to N minus 1. Z is a present value random variable for this insurance. And here we have the PMF. The individual dies within the first year, Kx equals 0 with probability Qx. The death benefit B0 is paid 1 year by the end of year 1 of the policy. So Z, the present value is B0 times nu. And then the rest follows. The expected value of Z, BK times nu K plus 1 times the probability K bar Qx, the summation from K equals 0 to N minus 1. And then the expected value of Z squared. We get this expression and then the variance of Z. Okay, so let's take a look at an example. For a special 2-year term insurance policy on an individual at age 30, death benefits are payable at the end of the year of death. The amount of the benefit, $4 if death occurs in the first year, and it's $8 if death occurs in the second year. The probability Q30 is 0.006, Q31 0.008, and I, the rate of interest, is 5%. Calculate the standard deviation of Z. First, we get the expected value of Z. If death occurs in the first year, the death benefit is 4. Multiplied by the present value factor, 1 over 1 plus I is 0.05, and then times the probability, Q30, 0.006. The second term, the death benefit is $8. The present value factor, nu square, 1 over 1.05 square. The probability of an individual dies in the second year, which is P30, 1 minus Q30 times Q31. This is a 2-year term insurance, so we only have 2 terms here. Upon calculation, we get 0.08055. The expected value of Z squared, similar structure. The death benefit square and the nu square. And then the second term, we get 0.50577. The variance, 0.499281, and then take the square root, we get the standard deviation. And we get the answer, 0.706599. Another example. After recovering from a severe car accident, an individual currently at age 37 purchases a 3-year term insurance. The face amount is 1,000. Given that the probability of surviving the first year is 60% of the survival probability in the given life table, and if the individual survived the first year, subsequent mortality probabilities will follow the given life table. The death benefit payable at the end of the year of death, I is 0.04. Calculate the actuarial present value, the APV, of this insurance. All right, the death benefit is 1,000. The notation, A x colon angle 3 with 1 above the x. By definition, we get this expression. And we need to get 3 quantities, Q37, Q38, and Q39. All right, so the first point. Surviving the first year, the probability is 60% of the survival probability in the given life table. And here we have Q37 is 0.000436. The survival probability is 1 minus Q37. We get this number. The probability of surviving the first year for this individual is only 60% of this. So we write it as the revised probabilities, revised survival probability, 0.6 times P37. We get 0.5997384. And then if the individual survived the first year, subsequent mortality probabilities follows the life table. We have Q38 and Q39 respectively. From this, we can get the actuarial present value for this insurance. Okay, the first term in the bracket, nu is 1 over 1 plus I, and then times the revised value of Q37. This is the probability that this individual dies before reaching age 38, which is 1 minus the revised survival probability P37. And then the second term, U squared, times the revised value of P37 times Q38. The individual dies before reaching age 39. We have the revised value P37.599 and then times Q38.000463. And then the last term, we get this expression and all the numbers. Upon calculation, we get the APV for this insurance, which is 385.3864. Okay, so that's it for today's video. In the next video, we will cover whole life insurance.